To all in the next lecture of the propositional logic, that is on normal forms. So what is the normal form? Normal forms are standard forms, sometimes called canonical or accepted forms. So remember always that we call the disjunction by the or and conjunction by the and, right? So now a clause that contains only disjunction connective, it is called the disjunctive clause. And if our variables, propositional variables, all propositional variables are connected with the conjunction, only the conjunction, so that is called the conjunctive clause. Like if we have the three variables p, q, r, and here we see that our variables p, negation q, r, these are connected with the disjunction here only, so this is called the disjunctive clause. And next we see that our variables negation p, q, r, negation r, these all variables are connected with the conjunction only, so this is called the conjunctive clause. And if the variables are connected with the both conjunction and disjunction both, so this is not called the normal form. Now come to the conjunctive normal form. So what is the conjunctive normal form? If we have the disjunctive clauses, means we have the number of disjunctive clauses. So if we connect all the disjunctive clauses with the conjunction, so this is called the conjunctive normal form. Suppose we have like an example, we have this p or r, right? So this is a one disjunctive clause. And next one is we have negation q or negation r, so this is the another disjunctive clause, and this is the another proposition q. Now we see that our these disjunctive clauses are connected with the conjunction, right? So this is called the conjunctive normal form. Clear? Next, what is the disjunctive normal form? So if our conjunctive clauses, right, conjunctive clauses means like that p and negation q and r, this is our one disjunctive clause, and negation q and negation r, this is our another disjunctive clause. So if our conjunctive clauses are together with the disjunction, so this is called the disjunctive normal form. Like that we have, this is the conjunctive clause because here our variables, all variables are connected with the conjunction, and this is the another conjunctive clause, negation q and negation r, and these conjunctive clauses are joined, connected with the disjunction, so this is called the disjunctive normal form. Clear? So we take the more examples about the disjunction and the conjunctive normal form. So see, if we have this, so we see that this is, what is this, p and q and negation r and s, this is our the what is this is our the conjunctive clause, right? And this is, we see that this is again the one conjunctive clause, and this is p and s, this is again one conjunctive clause. So we see that our all these conjunctive clauses are joined with the disjunction, right? So this is called the disjunctive normal form. Similarly, if our the disjunctive clauses like p or q or negation r or s, and one another disjunctive clause is negation q or s and negation s, we have the propositions, and we see that all these disjunctive clauses are joined or connected with the conjunction, so this is called the conjunctive normal form. If suppose we have is like that, p or r and q or and negation q and p or negation q, so we see that here our here we use both conjunction and the disjunction, so this is not any type of clause, means this is not the normal form. If we have suppose negation P or Q or R, and another one is negation P and Q and R, so these both are the normal forms, right? Because here all variables, proportional variables, are connected with the one connective, that is the disjunctive. So this is the disjunctive clause, and here all variables are connected with the conjunction. This is the conjunctive clause. So both are these called the normal forms. Clear? Next, we now converting expression to DNF or CNF. DNF means the disjunctive normal form and CNF is the conjunctive normal form. So if we have given any proposition, any statement, so how can we express that in the form of DNF and CNF? So here we use these procedure to find our expression in DNF and CNF first. First one is, if we have any proposition in which we have the implication, by implication and the XOR. So first our work is that we have to remove all these connectives by the definition. Means how the definition, suppose we have the, how to remove this implication. Suppose we have the two propositions P and Q. So if we have suppose P implies Q, right? So what you can write, this P implies Q, always remember this property, this definition which says that P implies Q, this is equivalent to negation of P or Q. So always you remember this. P implies Q, this is equivalent to negation of P or Q, right? So we can remove our implication in terms of conjunction and disjunction is like that. Next, biconditional. So how can we convert our biconditional in form of conjunction and disjunction? You know that if we have the two variables P and Q, then in biconditional definition I told you that this biconditional, this is equivalent to what? P implies Q and Q implies P, right? So P implies Q and Q implies P. So when you convert this biconditional into the implication, so now after this implication you can use this negation P or Q in place of P implies Q. So our all your implication or by implication, that is converted into the your conjunction and disjunction. Means you can also write this is P implies Q. What we can write P implies Q? We can write this negation of P or Q, right? And this and this Q implies P. What we can write Q implies P by this definition, that is negation of Q or P, right? So like that we can convert our implies and by implies in the form of conjunction and disjunction. Similarly, the XOR. How can we reduce the XOR? Actually, we know that P, if we have suppose P XOR Q, so what does it mean? I told you in earlier lecture that this is equivalent to the negation of biconditional, right? Negation of biconditional P biconditional Q. So now you know how to represent the biconditional in the form of conjunction disjunction. So just you have to do the negation of this, then we can remove the XOR. Clear? Now second one is you have to use the negation inside, means you need to when you convert DNF and CNF, so you need to use the De Morgan's law if you have the negation in that. Suppose like that you have the negation of P implies Q, so when you apply here, so you use the De Morgan's law, right? Next, after that you need to use here the distributive law to find the DNF or CNF. And you can use many other connectives you can use here, like the double negation. Double negation means the involution, means if you have suppose in your proposition, in your solution you have the negation of negation P, so there you can use double negation, right? Because your negation of negation P is your P. And you can use idempotent commutative any law to convert your expression into the DNF or CNF. Clear? Now see how do we convert this. So now let's take an example, this converting to conjunctive normal form. We have given this expression, negation of, negation P implies negation Q and negation R, and the whole negation of this. So here we have to convert this into the CNF, means conjunctive normal form. So how to do this? First we see that we have this our expression. So this is equivalent to, first we apply here what I told you, that first we apply here in this implication we use our definition. And what says our definition? Our definition of implication means P implies Q. This is equivalent to what? Negation of P or Q. So most of the time it will be used here, right? So P implies Q, you can convert into the, means this is equivalent to negation of P or Q. So you use here this definition, here negation P is here, so negation of P, so this becomes negation of P or Q. So like that you have. Now what you do here, you have negation of negation P. So what you do here, now what is the negation of negation P? This is equivalent to P. What proved? By the involution law, double negation, right? Now after that what you do here, this is the negation of this complete whole braces. So you use here the what? You use here your the De Morgan's law, right? Because what says our De Morgan's law? Our De Morgan's law is that if we have the negation of P and Q, so what this is equivalent to negation of P, and this is and convert into the OR, and this is the negation of Q, right? So now you use here this negation of P or negation Q, and this and convert into the OR, because we apply here the De Morgan's law, and again the negation of negation R. After this negation of negation R, we can write this R by the involution law. So again we use here our the involution law, means double negation. So here this become the R. Now after that you can see here that this is the after that you have the, what you can do here, after that you use the De Morgan's law again, because this is the negation of P or negation Q. So when you apply here the De Morgan's law, so what is says that negation of P and negation of negation Q, right? Now again what you do here, this is the negation of negation Q, so it becomes the Q by the double negation or the involution. So you can write this is the Q. Now you see here, what is this form? Can you see this? What is this form? Here this is negation of P and Q or R. So can you tell me which type of form this? Yeah, this is the DNF, your DNF, disjunctive normal form, because this is the conjunctive clause and this is the separate variable. So these both are together joined with the our disjunction. So this is our the disjunctive normal form, and here we need to find the conjunctive normal form. So to find the conjunctive normal form, we use here again the distributive law. And what is our distributive law? That negation of P or R and negation and Q or R. So we use here the distribution law. Now you can see that this is our the what is this negation P or R? This is the disjunctive clause, and this is also Q and Q or R. This is the disjunctive clause, and these two disjunctive clause are joined with the conjunction. So this is our called the conjunctive normal form. So now this is convert into the our conjunctive normal form, our required form, right? So now this is equivalent to this form, that is the conjunctive normal form of this. Clear? Okay, so now next come to the next example. Here we have this proposition, and this expression P implies Q implies negation R and Q. So here we have to find the DNF and CNF both. DNF means the disjunctive normal form and CNF is the conjunctive normal form. So now let's do it. How can we find this? So first, how can we find this? here first what we do here, so here we use that this is our the expression, and so what is our expression here, that is P implies, that is our the P implies Q, right, and this is the implies negation R and Q, right. So now this is equivalent to, first what we apply, first we apply here our the definition and our implication definition. And what is the implication definition, this is our one compound proposition, this is another compound proposition, and these two compound propositions are connected with the implies, right. So now first we apply here our the definition, which says that P implies Q. What is P implies Q? Our P implies Q, I told you that this is equivalent to negation of P or Q, right. So we convert this is means the negation of this. So first we do the negation of P implies Q and or Q. So or and Q, what is our Q here? Our Q is this term, negation of R and Q. This is our Q here, right. Now we use here the definition. Next you see that what we do here, here we have the negation, now again we have the implication. So first we remove all these implication, by implication or the XOR. So again we have the implication, so again we use the again definition. So P implies Q are the negation of P or Q. So now this is the negation, and P implies Q, we write this is the negation of P or Q, right. And this is our the same negation of R and Q, clear. So this is, you can write here, this is by the definition, right. Next this is equivalent to, now what we do here, after that we use here are the De Morgan's law, right, because here we have the negation and before the braces we have the negation. So we use here the De Morgan's law. And what says our De Morgan's law? Our De Morgan's law is that we have to negation of negation P, and this or is converted into the and this become the negation of Q, clear. And this is our the negation of R and Q. So here what we do here, we use our the De Morgan's law, okay. Yes. So now this is equivalent to, now what we do here next, here we have the negation of negation P. So we use here our involution law or double integration, means our negation of P, this is equivalent to P, and this is a negation of Q, and this is our negation of R and Q, right. So here we use the involution law. So you can write here, we use here the involution or the double integration, you can write anything. Now after that we have the next one is so now you see that here this is the P and negation Q, and this is negation R and Q, and these are both what is this? This is are the conjunctive clause, and this is also the conjunctive clause, and we see that these two conjunctive clause are joined with the disjunction. So what is this? Actually this form are called the DNF. So here we find the DNF because this is our called the DNF. So up to here we find the DNF. Now next we need to find the CNF. So how to find the CNF? So to find the CNF, we proceed further and we use here the distributive law. So when we use here the distributive laws, so that is become P, and we use here the distributive law, so or, and it is the negation of R and Q, negation of R and Q and this is become and negation of Q or negation of R and Q, right? So we use here the distribution law. So now after that you can see that this is equivalent to P or, so we write this same P or negation R and Q. After that, what you do here? You use here again the distributive law. So when we use here again the distributive law, so it becomes R the negation of Q or negation of R, right? And this is and negation of Q or Q, negation of Q or Q. So now we see that this is negation of Q or Q. What does it give? Negation of Q or Q, if you see your equivalence laws, so according to that the negation laws apply here, means the value of negation Q or Q, this is T, true. So this is equivalent to true. So this is P or negation R and Q, and this is negation Q or negation R, and this is R the true, T. So here we use the negation, our negation law, right? So here we use R the negation law. Fine. After that, here we see this. If we have P or, suppose this compound proposition is our P or Q. So what is the P or Q by the identity law? Identity law says that P or Q is equal to P. What is our identity law? Identity law shows that if P and T, so according to the identity law, this is equivalent to P. So now we apply here the identity law. So according to that we have P and negation R and Q, and what it becomes? It becomes P. And what is P here? Negation of Q or negation of R, right? So this is for the identity law. Okay. Now next we have this, this is equivalent to, now you use here again the distributive law. So when we use here the distributive law, so it become P or negation R and P or Q and negation Q or negation R. So you see here, what is this form now? This is our disjunctive clause, this is again disjunctive clause, this is again disjunctive clause, and all these disjunctive clause are connected with the conjunction. So this form is called the conjunctive normal form, CNF. So like that you can find your DNF and the CNF from the given expression by using the procedure like I told you earlier. Clear? Okay. So now next is the method to construct DNF by truth table. That was the method to find if you have any expression, then you can convert the DNF and CNF. Now how to find the DNF by the truth table? So how can we find by the truth table of this? So first you need to find the truth table of the given proposition. After that, use the rows of the truth table where the proposition is true to construct mean terms. So what is the mean terms actually? Mean terms are those like that. Suppose you have the three variables P, Q, R, and we write suppose P and Q and R, or P or and negation Q and negation R. What is this? In the last steps what you read this is the conjunctive clause, right? This is the conjunctive clause. So which are the conjunctive clause that are also called the mean term. We say that these are the mean terms, right? Mean term. So mean terms are P and Q and R. So these is called are the mean terms. So what we see here, in after making the truth table, we have to see that which rows has the truth, and so according to that we have to form the mean term. So how to form the mean term? If the variable is true, so we see that we have the three variables, we have the values true or false. So we see that if our value is true, means P is true, Q is true, right, and R is true, so our mean terms we have to write P and Q and R, right? If suppose our variable is false, suppose your P value is true and Q value is false and R value is true, so how can you form the mean term? Means you form your mean terms by the negation, means you write that your mean term, if your truth values are true, false, true, so your mean term will be P because this is true, Q is false, so you write negation and negation Q, and R because R is true. So like that you form your mean term. Clear? After that we join all these type of mean terms by the disjunction. So this is our called the DNF. Clear? So now I think after the example you clear this. So if we take here the example of the DNF, we need to find the DNF, that is P or Q implies negation of R. So here we find the DNF by the truth table. So here we have this truth table. So that is we have here the three variables P, Q and R. So these are the truth values of these variables, that is true, 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 false, like that we have the 8 values are there. So now first we need to calculate P or Q. So what is P or Q? We have the two variables P, Q, so true or true. In the case of the OR, so our values are false. If both the variables are false, then it is false, otherwise its truth table values are true. So these values are false if both are the false, otherwise all values are true here. So this is all the true. Now after that we need to calculate negation of R. So if R is this, so negation of R is true, so our value is false, false, then it is true, true, then it is false, false, that true, true, that is false, false, that is true, true, now this is false, and false, that is the true. So now we want to find the P or Q implies negation of R. So now we apply the implication of this, and in the case of implication our truth value is false only if the second proposition is false, otherwise it is true. So here we see that true implies false, so it becomes the false, true implies true, that is true, true implies false, that is false, true implies true, true, true implies false, it becomes false, true implies true, true, false implies false, that is true, false implies true, that is true. So now what we did here we see that our rows which have the true value, so here we have this one true, this is true, this row is true, this row and this row. So here like that we have the 5 rows are there in which our proposition, our expression has the truth value. So now from these truth value we find out the mean terms. So what will be here the mean terms? Here you see that in this row we have the PQR is true, true, false. So what will be our mean terms here? So our mean terms according to this is, because P is true, Q is true, so P and Q, and so R is false here, so it becomes negation of R. Next one is true is here. So now see in this row we have the true, false, false. So it becomes our mean terms will be P and negation of Q and negation of R. Similarly, in the next row, we have the truth value is here, and this row is the values of PQR false, true, false. So according to that, our mean term is negation of P and Q and negation of R. Next, our truth value is here, and in this row we have the false, false, true. So what is the mean term here? This is the negation of P and negation of Q and R. Next one is here, this is truth. So here we have the values of P, Q, R, false, false, false. So it comes, the mean term is negation of P and negation of Q and negation of R. So like that we have the total 5 mean terms are there. So what is the DNF? So according to this, our DNF of this expression P or Q implies negation of R. So this is equivalent to the, we have to join these 5 mean terms by the disjunction connective. So when we join this by the disjunctive connective, so this is called the DNF. So now our first mean term was P and Q and negation of R, and we join these by the disjunction. So now the second one is P and negation of Q and negation of R, or negation of P and Q and negation of R, and this is connected with the negation of P and negation of Q and R, and another one is negation of P and negation of Q and negation of R. So like that we join all these 5 mean terms by the disjunction. So this is called the DNF. So clearly you have to find your DNF by the truth table is like that. So now come to the CNF. So how to find the CNF by the truth table? So here you need first you find the negation of F. So what is F here? Actually F is not here anything else here. If your F is any your compound proposition, given the any compound proposition, suppose we have the two variables P and Q. So suppose your P and Q is there, your required proposition, or P implies Q, or P or Q. So like that, any compound proposition which is given, to solve that, first you need to find the negation of this for the CNF. Second, you need to find the DNF of this negation of F. So because already in earlier slide you know how to find the DNF. So first you need find the DNF of this negation F, and after that you have to use your De Morgan's law, and by the De Morgan's law you have to again negation of this negation F, so it become your F, and this is after this expression this is your the CNF. So like that, suppose we have the two variables P and Q, and these 4 truth values are here. So our F means you have any given compound proposition, right? So suppose our F is true, false here. So first what we do here to find the CNF, first we need to find the negation of this. So what will be the negation of F? So negation of F here, if you have the true, so it becomes false, then it becomes true, that becomes false, and false becomes your true. So this is your negation of F. After that, what you do here in the second step, you want to do the DNF of the negation of F. So now what is the DNF of the negation of F? So find the DNF, first you need to find the mean terms. So what is the mean terms? Here you see that truth values is 2 here. In the 2 positions you have the true. So in this row you have the P is true and Q is false. So what is your mean term? Your mean terms here P and negation of Q, right? So this is your one mean term, and the another mean term is that you see here, this is your P and Q are false here. So your next mean term is negation of P and negation of Q. So these two you have the mean terms. These are the mean terms, right? Now after that you need to find the DNF of this, and what will be the now DNF? So your DNF is your negation F. This is the, we join these mean terms P and negation Q by are the disjunction. So when we join by the disjunction of these mean terms, so this is called the DNF, right? So first we find the DNF of our negation of F here. After that our purpose is to find the CNF. So how to find the CNF here? So for this you have to again use the negation of this negation F, means you want to use the De Morgan's law. So first we use here the negation of negation F. So this is equivalent to our F. So here we use the negation of whole of this. So it is P and negation of Q, or negation of P and negation of Q. So now here we have the negation in the before the braces, so we use here the De Morgan's law, because obviously here we need to use the De Morgan's law. So when we apply the De Morgan's law, so according to that we have the negation of P and negation of Q, and that is our or is converted into the and the negation of negation P and negation of Q. So here we use the De Morgan's law, right? Okay, so now next is the, now you apply here, you have this negation of P when you again you want to apply here the De Morgan's law, right? Because negation is here in your side, so you need to find the De Morgan's law again. So that is negation of P, or it becomes the negation of negation Q. And what is the negation of negation Q? Here you use your involution law. So according to the involution law, your negation of negation Q, it becomes your Q, right? So it is the negation of P or Q. Next, and now again you use here your De Morgan's law, and with the your double integration, the double negation or the involution law. So negation of negation P, it is become P, or negation of negation Q, it is become your Q. So now you see here you have, this is the negation P or Q. So this is the one disjunctive clause, and P or Q, this is the another disjunctive clause. So here we see that our these two disjunctive clauses are connected to the conjunction. So this form is called your conjunctive normal form, your CNF. Clear how to find the CNF? And now again you one more thing here, you see that these all are the mean terms. So if we talk about this here, we see that this is negation of P or Q, like that, these terms negation of P or Q, and this term P or Q. So what are these called? Actually these are called the max terms. Clear? Like that, these are the mean terms, and with the disjunction these terms are the max term. Clear? Okay, so now next come to the another example. Here we need to find the DNF and CNF of this expression. So now first we want to make the truth table for this, and after that we solve this. So what will be the negation of P? Negation of P here, this is false, this is false, this false is true, this false is true. So now what will be the negation of Q? That is true, so it become false, false becomes true, true become false, false become true. Now after that we need to first calculate negation of P or negation of Q. So what is negation of P or negation of Q? Means false or false, that is become your false, and false or true, that is true, true or false, true, true or true, true. Now next we calculate P by implies negation Q. So what is P by implies negation Q here? This is P, this is negation of Q. So by implication is that true, by implication false, so it becomes your false, true, true, so it becomes your true, false, false, it becomes again true, false, true, so it becomes your false. So now we say that this compound propositions we say that is A, and this compound proposition we say that is B. Now we need to find the implication both of these. So A implies B, so what will be A implies B, F implies F, that gives R the F implies F gives the true, true implies true, true, true implies true, true, and true implies F, it gives the false value. So now we have this. So here we need to find the DNF and CNF both. So first we find the DNF. So what is the DNF? So to find the DNF we need to find the mean terms. So and we find our mean terms from these three truth values, and from this our first give the P is true, Q is true. So our first mean term is what we have our mean terms, that is our mean terms are here P and Q, and another mean term is true, false, so it is P and negation of Q, and another mean term is false, true, so it is negation of P and Q. So like that we have these three mean terms. So when we join these mean terms with the disjunction, so this is our called the DNF. So what will be our DNF here? So our DNF is here P and Q, or P and negation of Q, or negation of P and Q. So this is our the DNF, right? So now next we find the CNF. So how to find the CNF? To find the CNF, first we need to find the negation of this, because in our earlier example we have this, we say that this is F, right? So now first we find the negation of F, means negation of this. So this is true, this is false, this is true, false, true, so it becomes false and it is true. So in this case we have one row is true only. So this is the for the DNF. Now we make the DNF of our negation of A implies B. So what is the DNF of negation of F? That is DNF is false, false, so it become negation of P and negation of Q. So this is the mean term of this negation of A implies B. And for the CNF we need to find the again negation of this. When we do the again negation of this, so it become negation of negation P and negation of Q. So now we use here the De Morgan's law. So according to the De Morgan's law and apply again the involution law, so that is negation of negation P, it is become P, and this convert into the OR, negation of negation Q is Q. So now we have the P or Q. So this is the our required CNF. Clear how to find the DNF and CNF? Okay, so now today's lecture is completed now.